Hi, my name is Ji Xianxing. My match number is CE100204. I am from Session 2, Group 1, Multivariable Calculus. I will present about the question 1 of the assignment. Let's look at question 1A1. Compute the multiple integrals of integrate 0 to 1, integrate 0 to square root 4 minus z squared, integrate 0 to y, sy, ds, dy, dz. First, we need to integrate dx first. We will get this answer, this equation. Then we integrate with y dy, we get these equations. Then we integrate with z dz, we get the final answer of the question. Let's look at the mapper. Yes, the equation. This is the equation of the question, and this is the answer for the equations. It will save with my answer. Yes, thank you. Let's look at the question 1A2. Double integrate 8 minus x squared minus y squared dA, where r equal x, y equal negative 1 less than x less than 1 and 0 less than y less than 2. Uh, when x equal to minus 1, y equal to 0, x equal to 1, 1 equal to 2, then we do the equation. We integrate with dy first, we get this answer. Then we integrate with dx, we will get the final answer. Let's look at the mapper. Yes, this is the equation of the question. Then we will get this answer. Thank you. Let's look at question 1b. Evaluate the following triple integrals by using the spherical coordinate. We need to convert this equation to the triple integrate 0 d phi d theta. So we need to find the rho phi theta first. Then we convert it to these equations. Then we integrate the d rho. We will get these equations. Then we integrate with d phi. We will get these equations. So this equation, yes. Then we integrate with d theta. We will get this final answer of the question. Let's look at the mapper. Yes, this is the equation of question. Then we get this answer. Then we simplify it. We'll get this answer. Thank you. Save your answer. Save your answer. Thank you. Let's look at question 1C1. By using the polar coordinate, evaluate double integrate x squared plus y squared dA if R is the region in between circle x squared plus y squared equal to 1 and x squared plus y squared equal to 4 in the first order. The first order means 0 to 90 degree, and these two equations to find the radius, and we need to convert this equation to the double integrate r d theta. We need to find the r and theta first, then we convert the equation to dr d theta. Double integrate dr d theta, then we will get this equation. Then we integrate dr first, then we get this equation. Then we integrate with d theta. We will get the final answer. That's the mapper. Yes, this is a question for the equation of a question. Then we get this answer. Same with my answer. That's same with my answer. Thank you. Let's look at question 1C2. By using the double integrals, find the areas of the regions enclosed by y equal to sin x, y equal to cos x equal to pi over 4, x equal to pi over 2. This is a graph to let us easy to know the areas of the regions. Then we do these equations. Then we integrate with y dy. Then we get this answer. This equation. Then we integrate with dx. We will get the final answer, which is bracket minus 1 plus square root 2 close bracket unit square. Let's look at the mapper. Yes, the map. This is the equation of the map question, and we will get the answer. Same with my answer. Yes, same with my answer. Thank you. That's all for me, and I will let the next group member to present the next question. Thank you.
Hello everyone, Assalamu alaikum. I am Abdullah Naji Abdullah Saleh. My matrix number is 2007-3. So today I will explain and present my part that I did. It's question 2. Question 2 have 4 parts, A and B and C and D. And the first part about A, we have to find the first partial derivative. As we see in the I, we have the question given as x squared times y over z raised to 3. As we see, we derivative, and finally we get the first derivative of that. It's equal negative 3 times x raised to 2 times y over z raised to 4. So in the II, we did the steps or the method, and we find after all the steps, it's equal cosine xy times y e exponential raised to y times z. So in the question 2, we have to apply chain rule if the z equal ln x squared minus 2y and x equal u plus v, and y equal exponential e raised to v. So as you see, we do this steps and method, all this, we find lastly the answer as you see in front of you. 2 times 1 plus u. As you see, we can continue reading this one. So in the part 3 or C, we have to find the function z x e raised to x sine y plus e raised to y cosine x. And you have to specify that with Laplace equations, dz over dx plus dz over dy equals 0. As you see, this is the equation. So we do all this proof and steps and calculation. We find lastly it's equal same as we did. So and the last thing, it's question D. We have to find the implicit defined as the function. As you see, we do all the steps and calculation. We find dz over dx as you see in front of you. So in the same question, we have part II. Let's have to find like what we did in I. So as you see, we do the calculation and we do the methods. We find it's in front of you, the answer. So we have to look in the software solution at its like improvement or improve. We find all the answer same what we do in calculation. As you see, we do all of parts in software. Thank you. Thank you.
Hello and Assalamualaikum. So today I'm going to present to you for question number 3, which involves topic vector calculus by using Microsoft software. So it consists of 3 questions. So this is question 3A, question number 1. So by using this coding, include the coding with student vector calculus and input the vector field based on the question that we want. So this is the question from the assignment. So just input it. It's just a simple. You want to find the curl and divergence. So we just input curl F and the answer for curl. This is the answer for curl, the blue color. And then input divergence. Divergence, the answer will become 0. So curl is actually acknowledged V cross F, while divergence is V plus F. So that is for question 3A. While for question 3B, input the vector calculus coding, input the plot coding, and input the force field. Based on the equation, we get 3x square I plus y square j. So we input the force field. So this is the force field. Okay. So this is the force field, and the graph that you see over here is actually we get from the question. It is like moving towards, how to say, this is the force C2 and the straight line is C1. So how do I get the field plot is actually over here. Okay. Here. I mean this column. Or do I get this from here? Because it's 0, 0, 0 to 0 and negative 5 to 0. So negative 5 is actually negative 180. So you will get this graph. Okay. Okay, and next, to get the work done is equal to F times derivative of R. So given that R is 3 t square, this is from the question, minus negative 180 t square. And use the differentiate coding, derivative of R, we will get 60 minus negative 360. And include the product and sub x t y 180t, and finally we will get the answer for work done is negative 3061 times 10 to the power of 10. So that is for the C1 curve work done. Well, for number 2, the difference is only over here. Over here. The same question, same graph for C2, but the difference is, sorry, the difference is over here, okay, t square. Just now I use t square is because the force is acting like a quadratic. Acting like quadratic, right? Means if in x and y, we mean y square stand for quadratic, but y cube stand for cubic. So this the difference is over here. It's now t square, but now become t to the power of 4. T to the power of 4, and differentiate, you will get this derivative of r and the product sub 180 t square with x equal to t, and finally the work done, we will get negative 3213 times 10 to the power of 10. So that is the work done. So it is not same. The for C1 and C2 value not show the same value, even though it is a negative addition. However, we know that the force is conservative or not. Based on theory, we need to find that is the vector field produce 0 work done. This means that if the divergence, if we use divergence, B the product F plus it is equal to 0. So based on I use Maple, and from the assignment I use the exact differential equation. From Maple, it shows that it does not get 0. So it means that the force field does not conservative. And from the assignment calculation, I prove using exact differential equation does not get same exact differential equation. So for method also show we get 6x plus 2y does not get 0. So the first is not conservative. Final question. Final question is over here. So final question is about surface area, surface integral. For to find equal with height of line. So from question we get z is equal to x square plus y square. Power z is equal to power root of x square plus y square. So this is given from the question. You just input the method and then use the surface integral formula for area, which is y plus zx square plus zy square. So how we want to find zx? Differentiate d to the respect of x to z, you will get this, and differentiate y to the respect of z, you will get this. So simplify. After we simplify, actually we will get 1. You will get 1 plus 1. This is will become 1. Actually, this is will become 1. So you plus 1 plus 1, you will get 2. 1 plus 1, you will get ds is equal to set 2, or power of 2, set 2. So from the question, you are given 2y square plus 4z square. And then you sub it into the radius. So why you want to do this is because we want to use polar coordinate. Because polar coordinate we cannot use longer, so we just input over here. Cos is equal to radius. So this is the polar coordinate. 2 pi or 360 to the 0, 9. How do we get 9? Is from the height of 4. 9 to 0, and after you input inside the polar coordinate, so the answer is from 4x6 to the 2 pi. So that is the surface integral of the group. So that's it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fadila Imanina binti Muhammad Adwas. So this is a multivariable calculus assignment. So I will represent question 4. A. Define Gauss theorem and Stokes theorem. Alright, this is the answer. The Gauss theorem and Stokes theorem. The Gauss theorem is surface that the total electric flux out of a closed surface is equal to the charge enclosed divided by permittivity. And this is the formula. Electric flux in area is defined as the electric field. The Stokes theorem, surface integral of curl of function over a surface bounded by closed surface is equal to line integral of particular vector function around surface. So this is the formula. For the question B, the outward flux of vector field, and this is the equation, and the question is given the cylinder is x squared plus y squared equal to 4, z equal to 4, plane z is equal to 0, and cone z is equal to square root x squared plus y2. The first question is sketch the graph of the surface. So here, this is my manual sketch. This is I do by myself using this question given, the cylinder, the cone, and the plane, right? And this is sketch from GeoGebra. Actually, the Z0 and Z4, the plane, you can see the blue one is the plane. This is 0 and this is 4. And then A is Z equal to square root x square plus y square is cone, and then the equation 2 is x square plus y square is equal to 4 is the cylinder. For the second question, find the division of this question. We need to find the division, and this is my calculation, right? D equal to dx, d equal to dy, d equal to dz time with y, x, y, and z. So I get dy over dx plus dxy over dy, and then dz over dz. Actually, dy dx is equal to 0, and dy we can cancel in the middle here. So it's left x there, and then dz over dz is equal to 1. So for this equation I got for division of this equation. Alright, for the question 3, use Gauss theorem to evaluate the flow of the vector field across the surface. Alright, this is a manual calculation that I get. Alright, firstly I made x squared plus y squared is less than 4, and then I made square root x squared plus y squared is less than z, and z is less than 4, and then the square root become r squared less than z, and then z is less than 4. So I get the range is r is less than z, and z is less than 4. And I use the Gauss theorem, so this is the formula. Alright, so we need the integration 1 by 1, and then I got this. This is the final answer. 32 over 3 pi. 32 over 3 pi is exactly get 33.5103. So when I do the coding MATLAB, right, this is the coding for MATLAB I made. Alright, when I run the section, right, I run the coding, I got 33.5102. Exactly same like my calculation, right? Exactly same like the calculator also. And this is the result for math.
Assalamualaikum, my name is Muhammad Faiz bin Hamdan. Today I want to explain about question 4c. First, we have to sketch the surface of the plane using these coordinates. Then we have to evaluate this equation using Stokes theorem. This is the manual calculation. First, we have to sketch the surface plane. Then, for question 2, we have to evaluate the equation using Stokes theorem. Like this. And this. And the final answer got 1/3. Next, we go to the MATLAB and then we insert the coordinate, then we run. Okay, this is for question 4c1, the figure, surface plane, and then this is coding for question 2. First, we have to insert equation here. Then for the last step is we have to integral to G010y1. Integral 2 is for double integral. Then we got the final answer. This is the final answer. Thank you.